Now to proceed with the rule, let's go back to the item and go to the graphic editor of the rule. Insert these instructions. The shelves and sides thickness, which we set here as a variable, then the dimension of the sanitary space, and under the various typologies as we have already described. The 501, the 501.1, which is a sub typology, are the left side and right sides. The 503 is the shelf that is under 503.5, is the one above 505, the back. What we obtain is something like of this kind, a very simple box where by changing the materials we can see how the box changes color, characteristics, or dimensions. Obviously, this is not sufficient for the various type of boxes managed by the type of shell in this variable. We'll do something more. Therefore, the result with different type of boxes is open shelf with doors and with ovens, with sinks, and the position for the wall cabinets and the structural shelves. Let's see the result. It's something like this when I put open box. If I put a box with the doors, I don't put the top but something different. When I have a sink, I put an aluminum joint shelf. And I leave the sanitary space completely open for the drains. This is the arrangement for the ovens and cooking hubs. This is the cabinet, which in reality is arranged for the wall cabinets, and therefore we see it in its dimension. And similarly, we have the cabinet prearranged for the wall cabinets with a draining rack or something of the kind. Going back to the rule, we can't go without noticing a certain disorder. It's true that we have used the select command. It's true that there are all the ones that are commented among them. Therefore, it's pretty simple to integrate. But if the rule should grow, we could find ourselves in difficulty. This is why we used from the beginning the macros. Let's take a macro called init and make sure that all of the variables have an assigned value. This macro here, we name it shell, and insert this information inside it. Let's highlight an extra element. Here we are directly using the shell type variable. Not wanting to do this and desiring to change the variable, I'll write here type, and to the rule I pass a parameter. Type equals $string open parenthesis underscore BSTR dot column 1 close parenthesis. The result is the same. We have just resolved it on 2 lines. It could be important for the type case to insert also the instruction parameters, which imports some defaults. Therefore, if I can't automatically pass type, it would be taken to 1. Now, for example's sake, we set a goal a bit more challenging. Here we have all of the pieces in orange lacquer, and in this case, it's difficult to think of lacquering all the sides. It's better to only think of it on the sides in view. Therefore, we should pass a parameter panel by panel, which indicates which of the 6 sides should be lacquered. To do this, we need to define a parameter where we write a series of letters or a matrix in which for a position we set if the element must be lacquered or not. In the case where it doesn't have to be lacquered, it will be treated with a basic color. The lacquering is only for the lacquered elements, therefore it's not for the wood that will always have their finish. Let's carry on with this pretty complex subject. Therefore, on this discussion of lacquering, nothing changes with the normal materials, but when we insert a lacquered material, what we want is the lacquered element to be concerned only to the parts in view. For the shell, like in this case, only the inside or the outside are in view because we have to place some elements. The bottom won't be lacquered where the plinth will be placed, and the upper part where the top will be placed. It's also possible that if the two bases are placed side by side, here we will manually do it. It will be possible to remove the lacquering from one of the two sides using these flags that we will specialize with the name later on. We have done this for open bases. For the bases with doors, the inside is only colored and only the edges are lacquered. We go back to the outside management in order to see it. The same thing for the sink, for the oven and cooking hub, and the same for the wall cabinets. We will also lacquer the bottom part. It's clear that the analysis that we make can be revised based on the need, and this should be an example. So how do we obtain all of this? Let's enter and find a script created which we have named LACQ that we are going to look at and analyze. The script will verify parameter 9 in which we have memorized the information linked to the structure. From this information in the fourth parameter setting, we have specified a 0 if the element is not to be lacquered, or 1 if it's to be lacquered. Therefore, this flag allows us to know if the element is to be lacquered or not. Then we set two colors, a normal one and one for the white that will remain the neutral, or we could enable another color or derive it from something else. We have just white for the time being. It's named WR Panello function indicates the element is not lacquered, which has the need of a bearing, a color, and of dimensions. Otherwise, something of this kind is done, and that is a function is named WR Panello 2, which provides to specialize the color for each side, and therefore, based on a mask that we have inserted in parameter 8, based on the position of the value of 1 or 2 of this mask, we will decide if the side is to be lacquered or not. Furthermore, we have entered the typologies, taking every one of these and inserting the delacquering script. This is for the 501, 503, 504, 505, 506, 508, 509, which are the typologies concerning the structure. At this point, at last, we have obviously modified the rule, and inside it something can already be seen, that each single element has a mask. The mask works on bit, where 1 means it's not to be lacquered, and 2 is to be lacquered. That is, take color 1 and take color 2. Therefore, front lacquered, back lacquered, right, left, top lacquered, bottom not lacquered. After a few tries, we have verified that this is a mask for every element. It was more complex for the sides where we make the mask with a series of variables. Therefore, in reality, we are to manage one of the variables, which is lato BSX, to show if the external door is in view or not. And the same applies to the right and left sides. We will see later on how to pilot these variables in an automatic way with a final recomputation script. Let's say that this is a base for the lacquer, what we are seeing, because for now it's required for the graphics. Then it will be necessary to understand how to calculate some prints for the lacquering, how to calculate the price of the lacquering since it's applied by actual square meters, and how to download the lacquering when it's required at the bill of material level. Here we have put the inside, which is obviously not lacquered, except when it's down open. Down means that it's not lacquered, except for wall units. This is how we make the lacquering string and obtain this result. It's good to practice on this function since it's not easy to understand, but it's comfortable for expanding different things. This gives an idea of the potentiality and expandability of the rules language. Here we have used some parameters, and we have christened them on how we wanted them on a script dedicated to design the element. Then the script will pilot situations that may be the more complex and difficult. This is something that may cause a little confusion. The parameters aren't recorded at 100%. The only thing that we may do is to make some notes when needed on each single parameter to understand what it means. Here is that when we have said parameter 9, number 9, field 5, we are referring to this entry here that goes in the variance table. Variant str is an entry that tells me 0 if it's not lacquered and 1 if it's lacquered. It's rather simple to understand. Maybe it's not easy to navigate on all of this information. Therefore, we suggest to get well acquainted with this before proceeding. Let's proceed with the fronts. As we can see, we have already given a setting to the fronts that we want to use. In particular, we see that the hinges have been designed externally. It's not necessary, obviously. This is a part of a script, but it will help to us to understand how the processes are done on the hinges. In the same way, some style choices won't be discussed now because the most interesting thing to understand is how the elements are made. We also see that the two structural variants for the shell and for the door aren't linked between them. This in fact is not correct in the sense that here we have a shell of the open type where we put some doors in front. Then the limitations are inserted at the item level. We have performed other operations, in particular inserting the variant to stabilize the shell's positions. Usually we have the shelves placed in the mid position. We may change the position of the shelves by simply writing new positions, even more than one separated by a semicolon. This will be useful on a later phase when we will make the job and when we will see how the doors that slams against the shelves positions would have to be automatically moved. All of these things are preparatory for the processing we are about to do. We have improved the finish variant by inserting a pair of columns for each finish. One to specify if it has shells or not, and one to specify if it has a handle or not. Obviously, it's easier to put the conditions directly in the column that refers to the element in hand, which in this case is the handle, in order to see it better. Let's enter the graphic. We see that we have inserted a front macro. But first we will concentrate on these compile scripts. These scripts were already supplied with the catalog. They are scripts that were inherited long ago, but it's worth to explain them at this point. Script AN tab is the generic one that holds the door's characteristics. This first instruction is interesting. Double comment inc is not a comment, but the fact that it includes other functions that we will find in the anta-include file. Therefore, here we will design the door. In this case, if it doesn't have any particular finish, it doesn't have handles, it doesn't have openings, it's of normal design. Otherwise, the hinges will be applied through the function cerniera hinges. Also, the movements will be inserted through the function open. Obviously, the hinges are divided in two parts. The one that remains linked to the element, which is the basetta, base, the part linked to the door that moves with it. Therefore, two parameters have been remade with the function cerniera to show the two specific parts of the hinge. The functions that draw the shelves, the one that draws the panels, and the one that draws the handles. By this standpoint, the drawing of the door is pretty complex. We may say the same thing for the drawer and the big drawer that have a design that here has a rather similar way with an opening, with the fact that maybe the big drawer creates the hole to insert the footprint of the element, and a series of situations that are managed through a shape. Argument that we will not discuss at this moment. Then we have the drawing of the interior of the big drawer. That is the hidden part which normally slides, and in this case it's made of 4 pieces, the lateral sides and the bottom. The inclusion script of the door here has various service functions that we will try to understand. The first one, shelves, concerning the fact that I want a drawing on the outside of the shelf. It's not used at the moment, and we will see it later on. The drawings of the hinges and the hinge bases in different positions on the door. Even here we could have used some 3D files, but we have preferred to make a drawing using the normal functions already present in 3CAD. If we want a drawing of a hinge base or of a hinge, it's just required to replace the WR panel with the WRX function through the WXtrude with the name of the file we want to carry over. Here we have inserted all of the opening sequences for the left door, for the right door, for the drawer, for all the situations that may be expanded to create various types of movements. These are simple because they concern the door and drawer normal opening. At last we have the handles with their exact placing on the door. The script isn't easy and neither immediate. It's rather genetic. It should be understood in most situations. It just has to be used as it is. Now that we have seen the scripts, let's go and check the front macro. Even here it's recalled passing a type from the outside. The first part shows the position of the shelves. If nothing is shown, we will manually insert it in the mid position. Therefore, we have inserted a variable grip that we have defined with the door mid position. Otherwise, we take the content of the variable. Then we have set a variable that gives us more or less the height of the drawer. And now for the shell, the height is 1/4 of the compartment, and it's debatable whether to do it differently or better. At this point, we enter into the structure of each single consideration, and for the open door, we only have to place the shelves, which also in this situation have a position in height, but above all, the lacquering flag previously seen. Here we have the situation with the door where we may use the variable PM, which is the variable differente. The variable PM is the one linked with this icon. Changing the content of this variable, the doors change their opening direction. PM can have value 1 or 3, depending on the side of reference. Obviously, we insert the left and right doors subtypology. When 2 doors are present, we insert half of the size for each door, and then the macro for the shelves. We repeat the same thing for the glass doors and the double glass doors. Then for the drawers and big drawers, we have made some modifications to the drawers functions, in the sense that we have inserted a flag that is in X4, and this establishes if the drawer is of glass or solid. In this finish, we put 2 big drawers with X4 that are equal to 0. In the number 8 management, we put X4 equal to 1. Here we have the combination drawer, big drawer, big drawer, big drawer, 4 drawers, and so on. Let's say that this is the setting we should have for all of the doors. It often happens that on the rule something slips away. It's not a problem since you can bring it back to the correct form. Let's review the functions. 2 doors, glass drawers. The setting we have given to the drawers is the following. We didn't put a normal handle, but we have inserted it inside the structure. Being a glass drawer, we have a frame around it. In the moment when we open the drawers, we see the structure of the internal element. We will conclude with this first part of the tutorial concerning the base. On the next exercise, we will see to insert the surrounding elements, such as the tops that goes on top of these elements, the plinths, and we will see how these elements are united together for the creation of a composition.